So before we can talk about the rational zero test, I want to show you how to write the general form of a polynomial. A general polynomial can be written as f of x is equal to an x to the nth power plus an minus 1 x to the n minus first power plus the next one will be an minus 2 x to the an minus second power, and so on and so forth. It keeps on going till you have a2 x squared, a1 to the xth, and a0, which is a constant. Okay, this is just a general way to write polynomials. For example, what it means is, if you have a polynomial like, let me give you an example. Let's say we have a third degree polynomial. Okay, so we have, let's say we have 2x cubed plus 3x squared minus 8x plus 3. Alright, all it means is the last term over here, which is our constant term, is going to be denoted by the last letter over here, a0. So in general, the constant term is also called as a0. The first degree is called a1. The second degree is called a2, and this one has a3. Okay, so in this case, if n is the highest degree or the degree of the polynomial, starting by the highest degree, in this case n is 3. N is the highest degree of the polynomial, the highest degree is 3. So how do you get 2? What do you do with n? 3 to get 2. 3 minus 1 is 2, right? So n minus 1, this is n minus 2, and so on and so forth. This is your n minus 3, or in other words 3 minus 3, the 0 degree term over here, constant term. Okay, so this is I'm just talking about a general notation or the general way to write the equation of a function. Now what the rational zero test says is that every single solution of a polynomial like this, okay, the solution will always be of the form of a rational of the form p over q, such that p will always be a factor of the constant term a0, and q will be a factor of the leading coefficient, the first coefficient, an. Okay, an. So let me write, in other words, a0 is just your constant, or your just the number part without any variable. An is your leading coefficient, or the coefficient of the term that has the highest degree, leading coefficient. Okay, so the solution will always be a factor of the constant over a factor of the leading coefficient of that form. What that means is, let's do an example now. Okay, for example, let's do the question that we were talking about before. Let's say f of x is equal to 2x cubed plus 3x squared minus 8x plus 3. Let's say we have a question like this. So what the rational test says is that every solution of this equation will be of the form p over q in such a way that p is a factor. P will be a factor of the constant term. What is a constant term here? 3. Factor, let me write it out, of the constant term, and q will be the factor of the leading coefficient. That's what the formula says, right? Or in other words, here the constant term is 3. So it will be a factor of 3 over, it will be a factor of, the leading coefficient here is 2. It's between the first and the last. So the last number goes up on the numerator, factors of 2 go in the denominator. So there are several different possibilities. What are the different factors that 3 has? Factors of 3. 3 could have positive 1 and negative 1 as a factor. Also, 3 could have positive 1 and positive 3 and negative 3 as a factor. These are the 4 factors of 3. So there are 4 possibilities in the numerator. What are the different factors of 2? 2 only has 2 factors, which is 1 and 2, positive and negative. Positive, negative 1, positive, negative 2. So there are 4 possibilities for factors of 2. Now we have to come up with all the different combinations of these fractions. So if I'm going to start with positive 1, okay, I could have positive 1 over 1, I could have negative 1 over 1. Then I could have, what are my other, with the 3, I can combine with positive 3 over 1 and positive 3 over 1, and I could have positive 3 over negative 1. I could have negative 3 over 1. I could have negative 3 over negative 1. We're just writing down all the different possibilities over here. Okay. I could also write, positive 1 with negative 1. Okay, I forgot to write that one over here. I could write positive 1 with negative 1. And negative 1 with negative 1. Okay, all the different possibilities of 1, the numerator with the first thing. So also I could now combine the 1 with the 2. So I could have 1 over positive 1 over 2, positive 1 over negative 2, negative 1 over 2, negative 1 over negative 2. I could have positive 3 over 2 and positive 3 over negative 2. I could have negative 3 over 2 and negative 3 over negative 2. All the different combinations. Some of the combinations are the same, so we're going to have to choose and pick the ones that are unique. Okay, let me tell you what I mean by that. So 1 over 1, this is 1 over 1, where we can say that, okay, 1 is going to be a solution. Is there any other combinations that will also give us 1? This will also give us 1. So this is basically the same. Negative 1 divided by negative 1 is also positive 1. So any other way we can get 1? No. Now these two possibilities give our answer to be, our answer could be a negative 1. Negative 1 over 1, positive 1 over negative 1. Both of them give us the answer as negative 1. 3 over 1 will give our solution as 3. Is there anything else that will give our solution as positive 3? Yes. Negative 3 divided by, this is really positive 3. Negative 3 divided by negative 1 is just a 3. So both these are basically the same. It's just 3. If you look at these two options, that's just a negative 3. 3 divided by negative 1 is negative 3. Negative 3 divided by 1 is also negative 3. So these two choices give us a negative 3 as our answer. Now let's look at the fraction parts of it. Let's see if there are any common solutions here. This says that the solution is 1/2. Is there any positive 1/2s here? That's going to be a negative 1/2. That's a negative 1/2. This is another positive 1/2, right? Two negatives makes a positive. So these are both going to be 1/2s. And we just discussed that they're both going to be negative 1/2. So negative 1/2 is a solution. This is a 3 over 2 and this is also a positive 3 over 2. That's another one. And these both are going to be negative 3 over 2. So the only distinct, there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possible solutions. 8 possible solutions. Okay, every solution of this equation, every single solution that this equation might have, and we know that this equation is only supposed to have a maximum of how many solutions? 3 solutions, right? Because the degree is, highest degree is 3. It cannot have more than 3 solutions. So all 3 of those solutions are among these numbers. We can predict them. It's going to be 3 of these 8 numbers are going to be the solutions of this equation. So how can we decide? So we can randomly choose and pick. If you're thinking about that remainder theorem says this, right? I'm going to have to erase this to show you something. So I'm going to have to clear this bottom part over here. This bottom part over here. So please take notes if you haven't done so already. So we know that the remainder theorem says that when you evaluate a function at a number, like if you have f of, let's say instead of x I try to put it 1, and when I do that, if I plug 1 in the place of x and I evaluate it, substitute it in the equation, and I find the answer, and if I get my answer to be 0, right, let's check this. 2, instead of x I put 1 cube, plus 3, in this equation instead of x I put 1, that's a square, minus instead of x I put 1, plus 3. When I do like that, what do I get here? 1 cube is 1, 1 times 2 is 2, 1 square is 1, 1 times 3 is 3, minus 8 plus 3. So we get our answer as 2 plus 3 is 5 plus 3 is 8, that's positive 8. So it cancels with the negative 8 and we get our answer as 0. So when this 0 is, remainder theorem says that when you evaluate a function at a certain number, whatever answer you get, that is your remainder. And by factor theorem, we can say that if the remainder is 0, then if 1 is a solution, we can say that opposite of positive 1, which is negative 1, x minus 1 is a factor. Okay, so remainder theorem and factor theorem are kind of connected like that. Okay, so what I'm trying to say is how is what we predicted the solutions are going to be one of these 3 of these 8 numbers, right? The solutions will definitely fall in the set of these 8 numbers. So when we try to check, we can use remainder theorem like this. We could check it using remainder theorem. We don't have to check for 2 because 2 is not in this possible. I don't have to check f of 2. I know it's not going to work because it's not part of this set. So if I want to predict the 3 solutions, I can randomly put, instead of choosing random numbers, I can put the numbers in this set in the place of x and see which of them gives me 0 as an answer. So that's how this is useful. We could also pick one of these easily. If you don't like the remainder theorem, we can also use synthetic way to solve this, because another solution could be, so I'm going to set this up for synthetic. Third degree coefficient, second degree coefficient, first degree coefficient, last. So now that I know that 1 is we just found out that 1 is a solution, so I'm going to put that 1 over here. So we know that when we go down, it's addition in synthetic, and when we go sideways, it's multiplication. Don't forget that. So there's no number here to add, so it's just a 2. 2 times 1 is 2. 3 plus 2 is 5. 5 times 1 is 5. That is negative 3. Negative 3 times 1 is negative 3. When you add, you get 0. That is your remainder. So this actually showed us that 1 is a solution in another way. Okay, you can do this by remainder theorem way or by synthetic way. So you're just randomly checking for numbers in here to see if it's a solution or not. I could check for another number if I want to. I don't always have to keep it for 1. We could check like a fraction. Let's check one of the fractions. Let's check if half is a solution. Okay, so half, so there's no number here, either put a 0 or just nothing here. So 2 times half is 1, 3 plus 1 is 4, 4 times half of 4 is 2, negative 8 and 4 is negative 6, half of negative 6 is negative 3, so we do get a 0. So this is a remainder is 0, so we can say that 1/2 is also a solution. Okay, and then so just narrows down our choice of solutions. We don't have to check every single thing. It narrows our choice of solutions that we have for this equation.